So we're going to do the problems that I have starred. So this is worksheet 7. We're going to do problems 7, 8, and then a couple on the back, and then we'll also do some things in worksheet 8. So if you have any questions, you can put them in the chat or speak out. And if you speak out, I'll just edit it out of the video for when period 6 gets it. But don't hesitate to stop me if you get confused. So problem 7, the first thing that we would do, remember from the video, hopefully we prepared ourselves by watching the video last night or over the weekend, but we're going to subtract 12 from both sides because we want to isolate the absolute value. So now we have 2 times the absolute value of x minus 5 is greater than or equal to -4. And then we want to divide both sides by 2 because then that'll get the absolute value by itself. So now we have x minus 5 inside the absolute value is greater than or equal to -2. One thing that's kind of important is that notice that this is a negative number, but I'm not flipping the sign because I'm not multiplying or dividing by the negative. So I only flip the sign if I multiply or divide by the negative. I don't flip the sign just because there's a negative involved. So I have greater than or equal to -2 here. So then the question becomes the thing that I have on that GeoGebra activity where you can get a ton of practice with this. The first question I ask is, should I continue to go further than this? And the answer is no, I should not continue to go further. No continuing, because I have an absolute value, which, as we learned from the video, essentially means distance. So in this case, our distance from x minus 5, which if I'm graphing this on a number line, I would have like some sort of distance from a center, which I'll talk about near the end of this class. But I have a distance from a center, and that's greater than or equal to -2. Well, that makes sense, kind of. I mean, a distance is always greater than a negative number. So because a distance is always greater than a negative number, this actually makes sense all of the time. There is nothing I can plug in for x that is going to make this untrue. So in order to like determine what my answer is all real numbers. So in this case, my answer is all real numbers. Now, what if this problem ended up being x minus 5's absolute value is less than or equal to -2? Well, there would be nothing I can plug in here that would make this work ever. So in this case, I would have no solution if this were my problem. So this isn't the problem, but if it was the problem, I would have no solution. Okay, problem 8. Again, if you have any questions, don't hesitate to stop me. So in this one, I'm going to add 12 to both sides. So now I have 4 times the absolute value of 3x plus 2 is greater than or equal to 20. Then I divide by 4. So I have the absolute value of 3x plus 2 is greater than or equal to 5. Should I continue? Yes, because I have an absolute value greater than or equal to some positive number. So that means I actually have to solve this problem. So as we learned from the video, I will break this into 2 cases. I have 3x plus 2 is greater than or equal to 5, and 3x plus 2 is less than or equal to -5. So when I break this into 2 cases, I now have the case where it's greater than 5 or less than -5. So I flip the sign and I change the positive to a negative. Now I can solve each of these. So 3x is greater than 3 after I subtract 2, and x is greater than or equal to 1. And this one, I have 3x is less than or equal to negative 7. X is less than or equal to negative 7/3 after I divide by 3. So I have these two situations going on. If I have a greater than or equal to or a greater than problem, this ends up, when I graph it, being an or situation. So I have greater than 1 or less than negative 7/3. This would be what the graph looks like. And if I want to write this in interval notation, remember that I can do interval notation. It basically kind of looks like what the graph looks like. So negative infinity to negative 7/3, bracket because this is filled in, union because there's a gap, 1 to infinity. So that would be the interval notation of the answer. Okay. Now we're going to do problems 9 and 10. Notice that these have restricted domains. So hopefully you watched the video related to restricted domains. And the reason why that is important is because we have to make sure that the only x values we have as our answers are in whatever the domain is. So let's do problem 9. I'm going to subtract 10 from both sides, and I have negative absolute value of 3x minus 12 is greater than negative 6. Now I'm going to divide or multiply by negative 1 on both sides. That gets rid of the negative. So now I have absolute value of 3x minus 12 is less than 6. Notice that the inequality sign changed because I divided by a negative number. Now what I have is, should I continue? Yes, because it is less than a positive number. And so if I graph this, it's going to end up being something that looks like this. I just have to figure out what the numbers are. So I'm going to break this into two cases. 3x minus 12 is less than 6. And 3x minus 12 is greater than negative 6. So I have these two cases going on. Now I just solve these. So 3x is less than 18 after I add 12. So x is less than 6. Then I add 12 over here. So 3x is greater than 6, which means x is greater than 2. So x has to be greater than 2 and less than 6. So that makes me kind of figure out what those numbers are. And if I'm writing this in interval notation, I would say 2, 6, both with parentheses because these are open circles. However, the problem says that I have only natural number answers. So that means that instead of having an interval notation or a graph that looks like this, I have to restrict my answers to only be the natural numbers. So the natural numbers are the numbers that are just the counting numbers starting at 1. So my answers are not every single number between 2 and 6, including all of the fractions and all the decimals and everything. I actually, I can't even include 2 or 6 because those have open circles. It's a strictly greater than or less than inequality. So my answers are just 3, 4, and 5. So I would graph the answer kind of like that. I only have 3 points as my answers. So that's kind of what happens when I have a restricted domain. I have to look at it. It was 2 to 6, not including 2 or 6. What things inside of 2 and 6 are natural numbers? And that would be 3, 4, and 5. Okay, number 10, I'm going to subtract 8 from both sides. So I have negative absolute value of 4x minus 2 is less than or equal to negative 10. Then I divide by negative 1. So I have absolute value of 4x minus 2 is greater than or equal to positive 10. I should do the problem. So now I end up with two cases. 4x minus 2 is greater than or equal to 10, and 4x minus 2 is less than or equal to negative 10. If I solve these, I get x is greater than or equal to 3, or x is less than or equal to, that would be negative 2, because that becomes negative 8, and then divide by 4 gives me negative 2. So if there was no restriction, I would say it would be negative infinity to negative 2 union 3 to infinity. But I have a restriction. I can only have negative integers. So those are the negative counting numbers. So if I look at the negative counting numbers, 2 is included in this because I have a less than or equal to sign. So negative 2 works, negative 3 works, negative 4 works, negative 5 works, and all the way to negative infinity. So how would I write that as a solution set? Well, my answers would be, if I were writing it as a solution set, I'd probably have to put dots here indicating that it keeps going forever. Negative 5, negative 4, negative 3, negative 2. I do not want to put dots after the negative 2 because this is a hard stop. This is where it ends. Okay. So that kind of summarizes some of the things that we learned on the videos. And I just did 4 problems for you on your worksheet. So that hopefully helps a little bit for you. But then in addition to that, I kind of want to talk a little bit about like what these things look like. So if I look at, for example, problem 8. If I look at problem 8, we know how to do this algebraically. Geometrically, what I want to make sure that we understand is that I can actually determine what the graph looks like based on this. So once I get to here, once I get the absolute value all by itself, I can already determine what the graph looks like pretty much exclusively from a geometry perspective. So remember from the video, we talked about the definition of absolute value from a geometry perspective. It's distance from a center. So if I have this situation and I'm looking at what I see here, this number, this 3, is kind of like what I have to divide by in order to figure everything else out. This number kind of represents my distance from the center as long as I divide by the 3. And then solving this for 0 figures out where my center is. So I'll go through it in all of the problems that we just did and show you that it makes sense. So if I figure out where this is equal to 0, so 3x plus 2, where that is equal to 0 is negative 2/3. I subtract 2, divide by 3. Negative 2/3 should be directly in the middle of the 2 values that I have here. So this should be my center, negative 2/3. Notice if I subtract 5/3, it goes over here. If I add 5/3, it goes to 3/3, which is 1. So this is my center. My distance, or another way to put it is the radius, is how far away these things are from the center. That is always this number divided by any number that's right here. So in this case, 3. So my distance is 5/3. And notice, if I subtract 5/3 or add 5/3, I get to these values. So the geometry of this can actually tell us what I'm going to get. That's also true over here. Notice that in this case, if I set 3x minus 12 equal to 0, I add 12 and divide by 3, I get x equals 4. Notice that 4 is the center of my graph. Then, if I take 6 divided by 3, that gives me 2, which is the distance or the radius. Remember when I initially graphed this problem before I realized there were domain restrictions? It was from 2 to 6. So I have the center of 4 and then a distance from the center or radius of length 2. Same thing here. If I graphed this, I never actually showed you what the graph of this would look like without the negative integer thing, but it was -2 to infinity and 3 to infinity, or I'm sorry, -infinity to -2 and 3 to infinity. Well, how do I figure out what that looks like geometrically? If I take 4x minus 2 and set it equal to 0, I get x equals 1/2. Notice that 1/2 is directly in the middle of -2 and 3. Then my distance, or my radius, is going to be what happens when I take 10, this number over here, divided by this number. 10 divided by 4 is 5/2. And notice if I take 1/2 plus 2.5, or 1/2 plus 5/2, I get 3. And if I take 1/2 minus 5/2, I get -2. So that's the geometric way of doing it. Any questions on this before I go to graphing really quick? Yes, you can solve them geometrically also, but you have to make sure that you show your work if you're doing that. Like, show how am I getting my center? How am I getting my distance? The number one thing you have to do is you have to make sure that you also take into account, like, if I have a problem like number 7, you shouldn't do anything with it. Like, once you get here, you should be done. You should realize that every single number that I plug in will work. But if you get to this step and you can continue, you can also use geometry for it. Anything else? Like, in this case, this would be no solution. But we also have situations that are kind of odd, like number 1. What happens if the absolute value is greater than 0? So I just want to make sure that we're kind of aware of this. Actually, I should go back real quick. This only applies, like when you said with the negative, it only applies after you get the absolute value by itself. So for example, here, there was a negative number on the other side of the absolute value, or of the other side of the inequality, but I have to get the absolute value all by itself before I make any sort of decisions. So then we also have these cases where it's kind of awkward. When is the absolute value of something greater than 0? Well, it's everywhere except at the very spot where it makes it 0, right? So if I'm graphing this, what is my center geometrically? My center is 5, because that makes this 0. Then what's my distance? My distance away is 0, so I don't have to like go anywhere to make these distinctions. Where is it greater than that? Where is my distance greater than 0? Everywhere. Except at 0. So my interval notation here would be -infinity to 5, union 5 to infinity. So I have weird cases like that. But generally speaking, yes, if you have an inequality that's greater than a negative number, you will have, with an absolute value greater than negative, all real numbers. Absolute value less than negative, no solution. And really quick, I'm going to do problem 2 for you also, just because I'm feeling generous. So I'll do it algebraically. 2x minus 5 less than or equal to 7. 2x minus 5 greater than or equal to negative 7. Add 5 gives me 12. Divide by 2 gives me 6. Add 5 gives me negative 2. Divide by 2 gives me negative 1. So I have x is less than 6 or equal to 6, and x is greater than or equal to negative 1. So I have this case. Well, now let's look at it geometrically just to make sure that I know what I'm talking about. So if we have, if we want to find the center, I take 2x minus 5 and set it equal to 0. I add 5, divide by 2, and that gives me 5 halves. 5 halves is right in the middle of negative 1 and 6, so that's good. What is my radius or my distance? That's 7 divided by 2. So in order to find 6 and negative 1, I also could have taken 5 halves plus 7 halves, which gives me 12 halves, which is 6. And then I could have done 5 halves minus 7 halves, which gives me negative 2 halves, which gives me negative 1. And that is right there. Okay, well, do you solve for the center and distance? You also need to show a number line. Yeah, you need to make sure that you follow the instructions. So when we're solving, like how do we actually give an answer? Like the answer is solving for x. So I cannot just report center 5 halves, radius 7 halves. I'm trying to find what the actual answers are. So in this case, what is my answer? My answer are all the x values that work. So my answer would be in interval notation, negative 1 to 6. If I don't give that as my answer, then I haven't actually finished the problem. Okay, so you can get the center and you can get the radius, but that doesn't mean that you actually have finished the problem yet. That's just the means. Geometry is the means for us to understand how to get to here.
Is the answer, are we supposed to include the line? I mean, the number, right? The graph and the interval notation?
On the test, I'm pretty sure it asks you to graph and give an interval notation for the answers. So you will need to do both. Any other questions on that? Okay, so can you guys see the new one, the worksheet 8? Sorry, I can't see your faces. Like thumbs up, yes, thumbs down, you can't see worksheet 8? Okay, I will figure that out. What about now? Okay, sweet. Okay, so we are going to do a couple of these that I starred, but apparently it didn't stay that way. So we're going to do problem 3, problem 5, and problem 6. So just a reminder, when we're doing absolute value graphs, the very basic, most simple absolute value graph that we learn is y equals absolute value of x. That's called a parent function because that's like the very basic, most simple thing that we can do. An absolute value of x is just the line y equals x when x is greater than 0. and the line y equals negative x when x is less than 0. So it kind of looks like a V. And then what we kind of learned from the video, and I know it probably went a little fast, but what ends up happening is, and we will spend a lot more time on this later in the week when we talk about transformations, but we can figure out where the vertex is and like the rate or the, I don't want to be incorrect mathematically, but the quote unquote slope of this and whether it opens up or down. So we can kind of figure this out just looking at the equation. So in this case, if there's some sort of addition or subtraction on the inside of the absolute value, that gives me a left-right shift for the vertex. So in this case, the vertex is moving left or right. It moves left 2. And the reason that we can think about it as left 2, even though it's a plus, is what number would I have to plug in for x in order to make this 0? As up here, I plug in 0 for x, and that makes this 0, right? Up here, I would have to plug in negative 2 in order to make this 0. So x is going to be negative 2 for the vertex. And then y, what happens if I plug in negative 2? Well, all of this becomes 0. And then y is negative 1. So in general, this is left or right, and it's the opposite of what you see. So we move left 2. This one is up or down, and it's exactly what you see. So this one's down 1. So the vertex is negative 2, negative 1. The slope in this case is 3, and this vertex or this absolute value graph opens up. So I'm going to do a slope of 3 going to the right and negative 3 going to the left because this thing opens up. So that's kind of what this graph looks like. The 3 is positive. Sorry. So the 3 here is positive. In this case, the next one we do, it will open down because this number is negative. Sorry, I didn't say that. Okay, so we'll do 2 more. In this case, the vertex, there is no left or right shift because it's just absolute value of x all by itself. And then the y moves up 4. There's an up or down shift of 4. So 0, 4 is on the graph. Then I have the slope. It's not really technically a slope, but that's kind of how we'll think about it. The slope is 2, but it opens down because we have a negative 2 out front. So it's going to look something like this. Finally, number 6, vertex. This one moves left or right because there's something happening inside the absolute value. This one moves right 3 because if I sub in 3 for x, this whole thing becomes 0. So right 3. There's nothing over here like a plus or a minus or anything. So that means there is no vertical shift, so it doesn't move up or down at all. The slope is 1/2, but it opens down because there's a negative. So my graph will look something like this. So that's a really wide V, basically. Any questions on that?